so let's look at the fundamentals of factorization. The first part we're going to look at is factorizing an expression where you've got both a constant and a variable. So the first question is, what is a constant? Let's look at the concept of a constant. A constant is a number on its own, like 8, 1, 7, -3, -4. Those are all constants. And then a variable is any letter like X, A, B, C, D, E, etc. Okay. If I've got 16a plus 32ab and I am asked to factorize this, the first thing I'm going to look for is what number can divide by both 16a and 32a. And from here I can see 16 divides into both and a. So my common factor, my highest common factor is 16a. I write that outside of a bracket and I'm left with 1 because that cancels out to become 1 plus 2, this goes into a 2 and b. Alright, you try one. Suppose I've got 20b plus 5bc. Alright, let's have a look. So the first thing you do here for this question is you divide both by 5 and you divide both by b. So 5b goes into 20b 4 times, and we write that on the outside. We write 5b on the outside. We're left with 4 plus 5b cancels out, and that comes to that. So that's what you said, right?
Yeah.
Okay, super. Let's add 3 terms now. Okay, so in the next example, question number 2, I've got 3 terms that I want to factorize. Suppose I've got 15x squared plus 5xy plus 20x squared y. In this example, I can see that each of the numbers are divisible by 5.
Yeah.
So 5 goes into 15 3 times. 5 goes into 5 once. 5 goes into 20 4 times. So I can definitely take out 5. Another thing I can't possibly take out is the letter x or the variable x, because I can see in each term there is at least one x. But I can't take out y because there's no y over here. There is a y here and y here, but I can't take out y. So I'm going to divide each of them by x. And take that out. This is going to cancel, and I'll be left with 3 plus y plus 4 xy. And I'm done. And how do I know I'm correct? I just double check and I multiply it. 5x times 3, and this is incorrect, you can see. This is supposed to be 3x. 5x times 3x is going to give me 15x squared. 5x times y, 5xy. 5x times 4xy becomes 20x squared y. Correct. Right, you try one now. Suppose, okay, you got 12x squared minus 9xy squared plus 3x squared y. Alright, let's have a look. I can divide each of these terms by 3, so you're right, that's going to be 3. And I can divide each of them by x, so definitely 3x. And then 3 goes into 12 4 times, x goes into x squared once, giving me 4x. 3 goes into 9 3 times. X cancels out with x, and I'm left with negative 3y squared. 3 goes into 3, cancels out. X goes into x squared, cancels out, leaving me with plus x, and then y at the end. And all of that if I multiply it back in, I can double check this to see 12x squared here, 9xy squared, 3x squared here. Okay, let's move on to the next type now. Suppose I've got 3a plus ab, and this is factorizing by grouping. Plus 5w plus 4wy, and I want to factorize this. The first thing I have to do is put a bracket over the first two terms, put a bracket over the second two terms. I could also switch terms around. I could move this term over here, move this one over here, and then put them in brackets afterwards. But at the moment I can see that these two terms have a common a, and these two terms have a common w. I'm going to put a bracket around this and a bracket around this. I'm going to try and factorize it and see. If I do factorize this, I can take out a. I'll be left with 3 plus b. I can take out w, and I'll be left with 5 plus 4y. These two brackets can be common, but in this case they are not common. So we can't really do much because they're all different letters. W and Y, B and A are all different. So we will stop here, and that will be the answer. Alright, let's see if you can try one like this. 2cd minus 4c plus 6w minus 4wy. So in the first two, you put a bracket around that, and then you take out, divide both by 2c, and you'll be left with 2c on the outside of the bracket, d minus, and that goes into it twice, c cancels out completely, so d minus this cancels out completely, left with d, so d minus 2, and over here you can divide both of this by w, and both of this by 2, so you have 2w, correct, and that's going to be 3 minus w goes into 2, so you have 2y. Alright, cool. Now in the next question, we're going to have the same thing, grouping, but we're going to have some common brackets, okay? So let's have a look at factorization. So factorization, then we have common brackets. It's also a grouping bracket. So suppose I've got t squared plus 5t plus tu plus 5u. I'm going to attempt the grouping instead of moving anything around, because I could move this over here and I could move that over there, and that might work to form a group. But let's say I put brackets over the first two terms and the second two terms, and I take out a common factor by dividing both of the first two terms by t, leaving me with t plus 5, and dividing the second terms by u, and leaving with t plus 5 in a bracket. Now I have a common bracket. I have a common bracket in between the plus. If you look at it as a unit, I can see that this pluses that. And that's multiplication, and that's multiplication, hidden multiplication. I can see that if I divide this side and I divide this side outside the plus, so on the left hand side and right hand side of the plus, if I divide each of them by t plus 5, it'll become t plus u. left behind, right? But whatever we divide, remember, we put it in a bracket. So we're going to put t plus 5 in a bracket, and then we'll be left with t plus 0. All right, you try this one. Let's suppose I've got CD minus 5C plus 4D minus 20. Okay, so the first thing here is I can divide each of these by C. So, and I can put a bracket around there and divide this one by 4. So then that becomes C, and like I said, D minus 5. 4 comes out of here, you're left with D minus 5. Now, if you look at the left-hand side, that's one term on its own. And the right-hand side, that is also just one term on its own, with a common bracket, D minus 5. Almost like if I replace D minus 5 with the letter K, because it's the same thing, it would be like CK plus 4K. And then I can take out K, I'll be left with C plus 4. If I divided it by K. And then replace K with D minus 5 at the end, and be left with C plus 4. I could use the K method. This is called the K method. The K method is the method of substitution, which basically says if you've got something that's common in any expression, you could replace it with the letter K temporarily, and then at the end replace it back. If I don't use the K method, I can simply just divide each term by D minus 5. So take that out as a common factor, keep it in the bracket, and then you'll be left with C plus 4. Okay.
Okay.
Okay, let's go to the next topic. The next one is called factorization, but difference of squares. Factorization. So factorization using difference of squares. So let's go to typical examples like suppose I've got x squared minus y squared, and I want to factorize this. The first thing I notice is that if I put this in a bracket as x, y, and xy, and I put a plus and I put a minus, it will multiply out and the middle term will disappear. Because they'll be exactly the same but different signs. And they'll end up disappearing. Getting back to my question. When I factorize the difference of squares, it's built on this idea. It's built on the idea that if you're given a term x squared plus xy minus xy plus y squared, and you use grouping, then this becomes a minus. So this would become x plus y minus, take out a common bracket. From the common bracket y, you've left x minus y. Just double check that. So this is going to be x minus y squared. If I take out a minus, because minus times a minus is a plus. Suppose this was plus, okay, and I have a common bracket of x plus y and x minus y, that is better, then that's what I'm looking at. Alright, I'm not actually taking out a minus here, so the only time this would change into a negative is if I have initially a negative here, and I take it out, it'll become a positive. Or if I want to remove a negative from here. Right, but going to the simple part, if you look at it basically, we're taking that letter, placing it twice, taking that letter, placing it twice, and then putting opposite signs in. Another example is, suppose I've got 100 minus b squared. Open up two brackets, put the square root of 100 at the front, and then put the square root of b squared at the end of each bracket, and then put plus minus. Another question, suppose I've got x squared y squared minus 16 z squared. Open up two brackets, square root x squared y squared gets you xy twice. Square root 16z squared gets you 4z twice. Put a plus, put a minus. And now you've got a common bracket, and so alright, let's try this one here, see if you can do this one. Suppose you've got x squared minus 81. Yeah, so it's going to be x plus 9, x minus 9. Done. Alright, good. What happens if I've got x squared y squared minus 1? If I can fit it in there. Try that. Yeah, that's right. It'll become xy minus 1, xy plus 1. Perfect. Alright, let's go back to grouping quickly, and let's just make sure we got the concept of grouping where we have a negative involved. Okay? Just to make sure we got that right. And what does it mean when we do take out a negative from a number? So for example, let's suppose I've got 10bf plus 25bg minus 21p minus 14p. Okay? So from this here, if I take out, well, let's first put the brackets in. And at the moment I put a bracket over here, I've got it, because this is a negative, alright, it'll become a positive. And the reason is because the bracket, what the bracket does, it takes out a negative. So if I put a bracket over here, it becomes a positive. If I leave it without a bracket, it's a negative. But if it's a negative, I put a positive. Because when I multiply the negative back into the bracket twice, I end up with negative 21p minus 14p. So that's a big one there. That's a big error that can be made there. That becomes a positive, and now I'm dealing with a positive. I'm going to divide both of them by 5, p, here. Divide each of these by 3, p. So that means that if I cancel this out, let's first take out the 5p out of the first bracket, and I'll be left with 5 goes into 10 twice. P cancels out, so 2f. 5 goes into 25 5 times. B goes into B, cancels out. 2f plus 5g minus 3p goes into there 7 times. Oh, why did I say 3? 3 can't go into there. That should be 7, right? 7p. 7 goes into 21 3 times. And 7p comes out from the outside. If I'm not mistaken, this looks like it can simplify. Yeah. It should be 7p cubed. That makes sense. And now 7p goes into 14p, which is 2, and I'll be left with 2p. Just to remind you that that is a plus and not a minus, which is okay. Okay. So we've done the first part, which is normal binomial factorization. We've done grouping, finding a common bracket, and we've done difference of squares. All right, before we move on to the next part, which is trinomials factorization, let's do one question of each and let's see if we can do it. Okay. All right, I'll give you a few questions. All right, so we're going to try this for now. All right, suppose I've got 15xy plus 5xt. Question 1. Question 2. I've got 29y squared plus 77yr plus 21y squared r. Question 3. Those have got bc minus bb minus c plus d. Question 4. 5y squared plus 5yz plus zy plus z squared. Okay, question 5. X squared minus 1. Question 6. X squared y squared minus 25 z squared. Practice and type there. Okay, so let's go through every one of these, right? So the first one over here, I can take out a common 5 because I can divide each of these by 5, and I can also divide it by x. So I'm going to take out 5x. 5 times 3 is 15. X is gone, and 5 goes into 15 3 times. Y is left behind. 5 disappears here, plus c. The next one, what we have here is the following. So we've got a common, it's not a trinomial, but we can take out a common 7 of each. And we can also take out y, but we can't take out r, so 7y would be in front. And we just divide each of these. So it's going to be 7, that will be y plus 11 r plus 7 goes into 21 3 times. Y goes into y squared, y times, and yr. The next one we put a bracket over here, put a bracket over here, and put a negative here. Don't forget to change that into a negative. I now take out a common b from each of these. C minus d is left behind, minus c minus d. And now I have a common bracket, c minus d. Now what happens when I remove a bracket completely? It gets replaced with 1. If I take out c minus d as a common bracket, and I divide it, I'll be left with b minus 1 in the second bracket. Alright, for the next one, grouping, I'm going to put 2 brackets on each side, and I can take out 5y for the first bracket, 1 bracket at a time, and I think this was supposed to be z. That's what you were asking me. Yeah, so that's supposed to be z.
I put it as 2.
Alright.
That's why I didn't do it.
Alright, so let's just suppose it's z goes in. That's fine. That's going to be 5y, y plus z, plus z, and you'll be left with y plus z. And we can take out a common y plus z over here, and we'll be left with 5y plus z. Okay? So y plus z, y plus z, 5y plus z. Left behind. The next one is x minus 1, x plus 1. And the last one is going to be xy minus 5z, xy plus 5z.
Yes.
All right, cool. Let's move on to the next part now, some trinomials. So we're looking at factorization, trinomials, and the first question I got here is, suppose I've got x squared plus 7x plus 12. And I want to factorize this, so I'm going to put it into two brackets, firstly, and I'm going to look at the last term, 12, and find all the common factors of 12. So 12 times 1, 2 times 6, and 3 times 4. And looking at each of those common factors, which of those add to the middle term, 7? This can get me 13 if I add it, or 11. This can get me 8 if I add it, or subtract it, I get 4. If I add this, I get 7, or subtract it, I get 1, or negative 1. So I can see that is where the solution lies, 3 and 4. So I need to multiply 3 times 4 in my bracket, the last two terms, to get 12. And specifically 3 and 4 because that will get me 7. I notice that the signs are all positive, so in this question, I'm just going to put plus all around. And the first two terms get me the first term. So x and x. And now I'm done. I factorize it. I can do a quick check to see if I'm correct. So I write it out. And I multiply it out, I can get x squared plus 4x plus 3x plus 12. And 4x plus 3x is 7x. So yep, it works. Gets me back to my question. Right. You try one of these. Suppose you got x squared plus 11x plus 30. Sounds good. That's perfect. All right. So 30 will be 5 times 6 because 5 plus 6 is 11. So yeah, x plus 5, x plus 6. Done. Let's try another one. Actually, question number 2. Let me do this one first. Suppose I've got x squared minus 15x. Well, let's make it another one where we don't have a... Yeah, let's not. X squared minus 15x plus 56. 7 times 8 gets me 56. And so I know I need 7 and 8 to make x and x. Now the signs over here cannot be positive because I need to get to negative 15x. So I need negative 7, negative 8. So I need negative 7, negative 8 to get to that. And in question 3, I've got x squared plus 3x minus 28. The negative is now at the end. Let's first look for the terms that will get to 3. So 7 times 4 is 28. And 7 minus 4 plus 7 minus 4 becomes 3. So let's open up this bracket. X over here, x over here, 7 and 4. Now we've got to do the signs last. Put the plus next to the 7, because that'll get you plus 7x. And put the minus next to the 4, because that will get you minus 4x. And together, will get you plus 3x. And I'm done. The next one, Suppose I've got x squared minus 3x minus 28. Again, this will be 7 times 4. So I know brackets will be x, 7, 4. Signs we have to be very careful because now we need to get to negative 3. So it will be negative 7 plus 3. Right, plus 4. To get to negative 3. So here I will put a negative in front of the 7 now, and a plus in front of the 4. And you can see those two questions, the sign is swapped, and it gives you a different answer. So you have to be very careful with the sign. If the sign is in the wrong place, it gives you a different answer. Alright, try this one. Suppose you got x squared plus x minus 12. X squared minus 42x plus 437. Keep a calculator handy for the last one if you need. Alright, cool. I think that's all good. So let's have a look at the first one. The first one, we got 12. So we're going to go 4 and 3. Open up the bracket. 4, 3 plus 4 minus 3 x. The second one, x, and looking at 437, it's 19 times 23. You're saying, right? 19 times 23. But it's going to be minus 19 minus 23. Okay. Because that will get you negative, and 2 negatives get me a positive. Well done.
Mm-hmm.
Alright, I'm going to look at the last one now, which is the factorization of trinomials. But now we're going to have two factors. Alright, let's suppose I've got the following. Well, I've got 3x squared plus 17x plus 20. I'm first going to look for factors of 20, which is like, let's say, 4 times 5. And then factors of 3, which is 3 times 1. I'm going to bring these two factors in to play. And what I'm going to end up with is something like this. 3x and x, 4 and 5. Now, in order to get the middle term, I have to probably keep a pencil handy and then erase this, or I can use another method as well. So if I multiply the outer two terms, that becomes 15. If I multiply the inner two terms, that becomes 4. And if I put plus and plus again, it'll become 19. And that's not what I need. I need 17. So maybe I decide, okay, well, let's swap it around. Let's leave the 3x here. Let's leave the x here. But let's put 5 first and then 4. Let's see if that makes a difference. 3 times 4 becomes 12x. 5 times x becomes 5x. And there we go. 17 comes up from there. So all I need to do now is put a plus here and a plus here, because that'll give me plus and plus to get me plus. Alright. Let me do another one before we try one. Let's suppose I've got 5x squared plus 18x plus 9. The first term is a prime number, it's simply 5 and 1. The second one can be 9 times 1, it can also be 3 times 3, so we have to try each one until I get it right. I could have tried 2 times 10 here as well, and that would have given me 30 and 2. And I could have then went to 20 and 1, and that would have given me 60 and 1, which is too much. Oh, looking at 4 and 5, I chose that specifically because I like to work from the numbers that are closer to each other and on the way out. So for example, 9 and 1 I would check last. But I would check 3 times 2 first, if it works. So let's go ahead and check this one out. So I'm going to put 3 and 3 on the right hand side because that gets me 9. 5x and x on the left hand side because that gets me 5x squared. And then outer 2 becomes 15x. The inner 2 becomes 3. And so we got plus and plus. And that's 18x. That works. Because 3 plus 15 is 18. Okay, try this one. Here at the bottom. Suppose you got 3x squared plus 16x plus 21. Alright, let's have a look. So definitely 3x and x, correct? And then this is 7 times 3, let's say. And I put 7 over here and 3 over here. That'll become 9 and 7, and that gives you 16. That's 3 times 3 is 9, and that's 7. 9 plus 7 is 16. So yeah, 3x plus 7 and x plus 3. Okay, let's go to the next one. The next one is a continuation of that. So let's suppose I've got 15w squared plus 14w minus 8. Over here now, I'm going to choose 5 times 3 first, and I'm going to choose 4 times 2 first, and see if it works, okay? But I'm also testing it. It's a test, it's a trial and error, right? So 5w, 3w. That'll give me 15w squared. 4 and 2. And that gives me 8. One has to be positive, one has to be negative. So let's do our quick test by multiplying the outer 2 and inner 2 terms together. So this is going to be 10w, 12w, and there's no ways I'll get to 14. So we know that's not going to work, right? Alright, so let's go out of here, and let's start again. Let's keep those the same, and let's swap the 2 and the 4 out. That becomes 20, and that becomes 6. And 20 minus 6 is 14. So plus goes to the 4 to get me plus 20, and minus goes to the 2 to get me minus 6 to get me plus 14, and now I'm done. Okay. Alright. So try this last one over here. Suppose I've got 14w squared plus 17w minus 6. So the first thing we got here is 14, and I can say this is 7 times 2, and this is 3 times 2, and if I put this in a bracket as a start, possible start, now we put 3 here and 2 here, that comes to 14, and that comes to 6, so that's wrong. If I erase it, swap it around, 2 here and 3 here, that becomes 21 and 4, and that can get to 17, but one has to be plus, one has to be minus, and yes, this is a minus, so that's positive. This will be negative 2, positive 3, because negative 2 times positive 3 is getting negative 6. Anyway, so that works out. So the final answer here, 7w minus 2, 2w plus 2. Okay.